Hello. My name is Humphrey Solomon Jr. Welcome to my channel. Our today's video presentation is about ellipses in conic sections. Before we continue, please watch my other tutorials and please subscribe to my channel, thank you so much. Okay, let's define an ellipse. In analytic geometry, an ellipse is the set of points P on a plane, such that the total distance of point P from two fixed points is constant. The fixed points are called foci, plural of focus. As you can see in the figure, the blue and red lines represent the distances of different points on the ellipse from the two fixed points, foci. And anywhere the points are, the total length of the distances will never change. Now, I will show you the different parts of an ellipse. The foci, these are the fixed points of the ellipse. And the vertices, these are the endpoints of the major axis. And the major axis, the chord that passes through the foci that connects the vertices. We also have the minor axis, the chord that passes through the center of the ellipse, and is perpendicular to the major axis. The center of the ellipse is the midpoint of the major axis. And the extremities of the minor axis, these are the endpoints of the minor axis. Now we go to the measurements. The distance from the center to a vertex, V1 or V2, equals a. Thus, the length of the major axis is 2a. And, the distance from the center to an extremity of the minor axis, B1 or B2, equals b. Thus, the length of the minor axis is 2b. And, the distance from the center to a focus, F1 or F2, equals c. And the relationship between a, b and c is represented using the Pythagorean theorem. You can see that in the figure, we have a right triangle. Here, a is the hypotenuse and it is the longest. Next, the latera recta, these are the chords that passes through the foci and are perpendicular to the major axis. The length of LR is 2b squared over a. Then, the eccentricity is c over a. What is eccentricity? For a given conic section, this is the mathematical constant that is the ratio of the distances from any point of the conic section, to a focus and the corresponding directrix. Now for the equations of the ellipse. If the major axis is horizontal, the quantity x minus h squared has a bigger denominator, because a is longer than b. If the major axis is vertical, the quantity y minus k squared has a bigger denominator, because again, a is longer than b. For the general form of equation for an ellipse, we have ax squared plus cy squared plus dx plus ey plus f equals 0. Where a is not equal to c, and have the same sign. Let us try identifying the parts of an ellipse given its equation in standard form. Given the quantity x minus 2 squared over 25, plus the quantity y plus 1 squared over 9, equals 1. The a squared is 25 and the b squared is 9. Here, we can say that the major axis is horizontal, because the x quantity has a bigger denominator. Then, the center of the ellipse is at 2, -1. And the length of a is 5, and the length of b is 3. This tells us that the length of the major axis is 10, and the length of the minor axis is 6. Using the Pythagorean theorem, the length of c is 4. Now, the length of the LR is 18 over 5. And, the eccentricity is 4 over 5. Now we move on to writing the equation of the ellipse in general form. We have an example, quantity x minus 3 squared over 4, plus the quantity y minus 1 squared over 9, equals 1. We need to remove the denominator first, so we multiply both sides by 4 times 9. This will give us 9 times the quantity x minus 3 squared plus 4 times the quantity y minus 1 squared equals 36. And then we expand the x and y quantities. After that, we distribute 9 to the x quantity, 4 to the y quantity. After that, we will rearrange the terms. We will put the x squared term first followed by the y squared term, and then we will simplify the constants. So the general form of equation for this ellipse is 9x squared plus 4y squared minus 54x minus 8y plus 49 equals 0. But how do we do it in reverse? This time, write the equation of the ellipse in standard form. We have 9x squared plus 4y squared minus 36x minus 8y plus 4 equals 0. First, we transpose the plus 4 to the right, and group together the terms with x and y. Second, we factor out the 9 from the x quantity and 4 from the y quantity. Third, we use the completing the square method for the x and y quantities. Make sure to add on the right side the same quantities we added on the left side in completing the squares of the x and y quantities. This makes sure that both sides of the equation remains equal. Next, simplify the right side of the equation. And then, divide both sides by 36, so that the right side will become 1. Also, we have to simplify the left side of the equation. This will give us the equation of the ellipse in standard form, the quantity x minus 2 squared over 4, plus the quantity y minus 1 squared over 9, equals 1. You can try this next one. You may pause this video if you need more time in solving. Or you can go back to our previous example and use it as your guide. 5, 4, 3, 2, 1. Okay, here is the answer. Check if you got the same answer. Now, let's go and try graphing. Graph the ellipse, quantity x plus 2 squared over 25, plus the quantity y minus 3 squared over 9, equals 1. First, we need to identify its parts and properties. The major axis is horizontal, because the x quantity has a bigger denominator. The center of the ellipse is at -2, 3. The length of A is 5, the length of B is 3, and the length of C is 4, using the Pythagorean theorem. The length of LR is 18 over 5, and half of the LR is 9 over 5, which is 1.8 in decimal. Half of the LR is needed in graphing an ellipse. Now we are ready to graph. Step number 1 is to plot the center of the ellipse at -2, 3. From the center, we plot the vertices horizontally at 5 units away, this is the value of A. From the center, we plot the endpoints of the minor axis vertically at 3 units away, this is the value of B. From the center, we plot the foci horizontally at 4 units away, this is the value of C. From the foci, we plot the endpoints of the LR vertically at 1.8 units away, this is half of the LR. Now that we have the points we need, we will use these points to draw the ellipse. Let's have another one. Graph the ellipse, quantity x plus 2 squared over 16, plus the quantity y minus 3 squared over 25, equals 1. First, we need to identify its parts and properties. The major axis is vertical, because the y quantity has a bigger denominator. The center of the ellipse is at -2, 3. The length of A is 5, the length of B is 4, and the length of C is 3, using the Pythagorean theorem. The length of LR is 32 over 5, and half of the LR is 16 over 5, which is 3.2 in decimal. Half of the LR is needed in graphing an ellipse. Now we are ready to graph. Step number 1 is to plot the center of the ellipse at -2, 3. From the center, we plot the vertices vertically at 5 units away, this is the value of A. From the center, we plot the endpoints of the minor axis horizontally at 4 units away, this is the value of B. From the center, we plot the foci vertically at 3 units away, this is the value of C. From the foci, we plot the endpoints of the LR vertically at 3.2 units away, this is half of the LR. Now that we have the points we need, we will use these points to draw the ellipse. Now, we find the equation of an ellipse in standard form given the following properties. In number 1, we have the vertices at positive and -5, 0, and the foci at positive and -2, 0. If we plot the vertices and the foci, we can see that the major axis is horizontal. And, at the middle of the vertices and the foci, we have the center at 0, 0. And, the distance from the center to a vertex is 5 units, the length of A is 5. And, the distance from the center to a focus is 2 units, the length of C is 2. Using the Pythagorean theorem, b squared is 5 squared minus 2 squared. This is 25 minus 4, so b squared is 21. Since the major axis is horizontal, we will use the standard form of equation for the ellipse with the x quantity over the a squared. Then we substitute the values we got. The standard form is x squared over 25 plus y squared over 21 equals 1. In number 2, we have the vertices at 1, 7 and 1, -3, and the minor axis length is 6. If we plot the vertices and the endpoints of the minor axis, we can see that the major axis is vertical, and the center is at 1, 2. From here we get a is 5, and b is 3. Since the major axis is vertical, we will use the standard form of equation for the ellipse with the y quantity over the a squared. Then we substitute the values we got. The standard form is, the quantity x minus 1 squared over 9, plus the quantity y minus 2 squared over 25, equals 1. In number 3, we have one vertex at 8, -3, the center at 2, -3, and the minor axis length is 8. We can plot first the given vertex and the center, and plot the endpoints of the minor axis. We can see that the major axis is horizontal. From here we can also see that the distance from the center to a vertex is a, which is 6 units. And the distance from the center to an endpoint of the minor axis is b, which is 4 units. Since the major axis is horizontal, we will use the standard form of equation for the ellipse with the x quantity over the a squared. Then we substitute the values we got. The standard form is, the quantity x minus 2 squared over 36, plus the quantity y plus 3 squared over 16, equals 1. Let me also share with you this helpful site I found in Google. emathhelp.net. This is a free online resource. You can find helpful math notes, equation calculators, and free homework help here. To use the ellipse calculator from emathhelp.net, you just need to search for ellipse calculator emathhelp.net in Google, then click the link here. And then, input the information you have for the ellipse and skip the unknown values. In one of our examples, I used the coordinates of the given foci and the vertices. Then, just scroll down until you see the calculate button. Click the calculate button and wait for the answer to load. This is amazing. This can help you check your answers after you solve, especially for self-assessment in some exercises. I hope I was able to help you learn about ellipse in conic sections. Thanks for watching this video. Don't forget to hit the like and subscribe buttons below. Also, click the bell icon to get notified when I upload my next videos. Please share this video with your friends.